In this lesson, we're going to take a look at measuring and how that leads to uncertainty and the idea of precision and also significant digits. So whenever we measure, we always have to guess. And how big our guess is depends on our measuring instrument. If it's a super precise instrument, then we're going to be guessing a little bit. If it's not a very precise instrument, then we're guessing a lot. It's like the difference between counting off steps with your feet and actually getting out a tape measure and measuring. Now, you can always guess a little bit more than what your device shows for certain. So you know if the end of the line you're measuring to is between two marks, you can guess 0.3 or 0.4 or 0.5. That all counts as a legitimate measure, but you can't divide it up again. That's it. That's a meaningless guess. It doesn't have any value. And that's why when two people measure the exact same thing, we might come up with two different answers. That's an uncertainty in our measure, but that's okay. But those digits at the end, the last one that you can guess, is still a reliable digit. It's what we call a significant digit, and we use it when we do mathematics with our measurements. We just have to make sure that we don't over-precise or over-report our precision. Now, what I mean by that is if we have these two lines, this black bold line up here and this black bold line right here, and I want to know how far apart they are, I'm going to go with 0, 1, and it's more than 1, it's less than 2, it's closer to 2 than it is to 1. So I'm going to guess 1.5 is right here, so I'm going to guess that's 1.6. Might be 1.7. I don't know. It might be between 1.6 and 1.7, but I don't know how far between. So 1.6 or 1.7 are legitimate measurements for this. But I can't divide it up smaller than that because I don't have any more degrees or graduations on this scale. There's nothing else there for me to do. But if I had a more precise measuring device, then I could make a more precise measure. And that's what I have here. So from the outside of the line to the outside of the line, I can see 1.1, 2, 3, 4, 5, 6. And then right here, is that a 0.2 or a 0.3 or a 0.1? I'm not really sure, but any of those would be valid. Two people might come up with the same or slightly different ones, but it's okay to say that. So I can say 1.63. I could say 1.62. If that was the case, the 2 would still be a guess. I can't say 1.630 because that 0 here at the end would imply that I knew this was at exactly 1.63, and I don't. I made a guess on the end. I don't have a precise enough device to say that that last digit there with certainty is 0. I'm uncertain about this, so I'm completely guessing about that. Now, that means this measurement, 1.63, has 3 significant digits, but this one would have 4 significant digits. That 0 increases the precision of my measurement, and that's not okay, not with this device. But if I had a micrometer or I had divisions between these divisions, then I could start making claims about this number. So, when do we know if we have a significant digit? That 0 I just showed you was significant because it increased the precision of the number. But not all zeros, wow, apparently I spelled zeros fun, not all zeros represent values. Some zeros just hold places. So we have to be careful with that. So any non-zero number that you see in a measurement is a significant figure or a significant digit. If it is a 0, it's only significant if it's holding a value. If it's holding a place, it's not. So leading zeros like 0.004, those are not significant. Trailing zeros are significant if they follow a decimal point. If they're between non-zero numbers, then they're significant because they're telling the value of that place. So let's take a look at some examples. 23.21 has 4 significant figures. Every single one of those is significant. They tell me a value. 20.31 also has 4 significant digits. Every single one of those is a value. 20.3, 3 significant figures. 20.30, 4 significant zeros. This 0 at the end does increase the precision. However, 100 does not have 3 significant digits because these zeros could be placeholders. I could write this as 1 times 10 to the second, and it would mean exactly the same thing. And I don't know if that's plus or minus 1 or plus or minus 25. So unless we're told explicitly that this is precise to the ones place, then this has got 1 significant digit. And we could actually write this as 1.00 times 10 to the second if we wanted to make sure that those zeros were precise. Or you could put a decimal point at the end without adding anything in to the end, because if I add something to the end, I added this 0.0, that 0 increases the precision, and it tells me the value of the tens place is 0, the value of the ones place is 0, and the value of the tenths place is 0. So this has 4 significant digits. So anytime you use a 0 to increase the precision of something, or it tells me the value of a place, it's significant. But if it's just holding the position, moving over a decimal point, then it's not significant.